Welcome back to the shop and to the channel. If you've been watching for at least a little while, you'll recognize this as the 1960 13-inch South Bend lathe that I picked up almost a year ago. I want to take advantage of the larger spindle bore for a project that I have coming up. And besides being a bit dirty and maybe needing some lubrication, the lathe itself is in decent mechanical condition. But there is one thing that I want to address before I actually start using it, and to me it's a bit of a safety issue, and that's with the way that the motor is wired. The cable from the three-phase power goes into this box on the left, and it's just a junction box. But more importantly, this motor starter or contactor on the right, the lathe is unplugged, is really kind of jacked up. It doesn't stay latched in the on position. And I'm just a little concerned that I could have an electrical issue with it, and I want to get rid of it. But I don't want to wire the three-phase directly to the forward reverse switch. Since I use a rotary phase converter for my three-phase, I want to add some circuitry here that will prevent me from trying to start the lathe unless I have the three-phase converter running, as well as add some overload protection. Even though the rotary phase converter is not on, there are still two hot legs that are leading up to the lathe, the two legs that come from the line power. Which means if I make a mistake and forget to turn on the phase converter and then I try to start the lathe, it's sending that 240 volts to the motor, and the motor's going to want to try to start, but it's not going to be able to. And leaving it on would likely burn up the motor. So one of the things I want to do is prevent this switch from being active unless it has full three-phase power. Before we go any further, I think it's prudent that I at least give you a bit of a warning. I am not an electrician. I don't play one on TV, and I didn't stay at a Holiday Inn Express last night. Well, even though I have a lot of experience working around residential voltage and even more experience with electronic circuits in general, take what I am showing you here as for entertainment purposes only. This is not a how-to. I feel pretty confident in what I'm doing is safe and will work, but if you are an electrician and you've worked with this kind of equipment before, if I'm doing something wrong, please point it out, because I want to be able to do this the safest and prudent way possible. So with that admonition out of the way, let's get on with the show. I will have some links to Amazon and eBay in the description from where I purchased all of these components for you to do your own research from. But this is the enclosure I intend to put them in, and I'll be removing the stuff that's on the back of the lathe currently. I've used this enclosure before for some other projects, and it seemed to work out pretty good. It does have a gasket on the lid, which should help protect the contents from any fluids that might get on it. I have this piece of 1/4-inch aluminum that I've already cut to size, and I've started laying out positions for these various components. I'll drill and tap some mounting holes for each of them off camera. I'll explain how I connected all these parts in a minute, but we'll talk about what they are. This first one here is just a breaker. This one over here to the right is a phase monitoring relay. This one here in the upper left is a thermal overload relay, and it has a dial on it that you can use to set the sensitivity. And this one here in the upper right is the motor contactor. And then I have this set of start-stop buttons. And with everything mounted to this piece of aluminum, everything will fit nicely in this enclosure and should be relatively safe, at least in the environment that it will be in. It won't be in, a rough industrial environment. This is going to be in my home shop, and I'll primarily be the only one that will be using this. Okay, so I'm going to try to explain this the best that I can with this very crude diagram. I hope it makes some sense. Down here on the left, we have our breaker, and this is just an on-off switch. The breaker's only job really is for short circuits. If it shorts out, it'll trip. It doesn't do anything with amperage overload like your household breaker panel does. This feeds into the input of the contactor. Coming out of that contactor on those same inputs, we're just jumping off of it, we're feeding into this phase monitoring relay. This phase monitoring relay is set up so that if it doesn't see steady three-phase power, this relay or this switch here remains open. Only when it sees three-phase power will this switch close. Now this contactor is essentially a relay, and so there's a coil. When that coil is energized, it connects T1 to L1, T2 to L2, T3 to L3. The output of the contactor feeds into this overload relay. This has a set of contacts on it that are normally closed. The output of this feeds into the motor or to the forward reverse controls. Now, as long as this overload protector is not sensing an over amperage condition, this contacts remain closed. If it gets too hot, meaning that there's too many amps running through it, there is a thermally sensitive piece of metal in here that will actually push these contacts open. That's important. We'll see that here in a minute. So the way that a contactor is wired up on a three-phase motor, or actually any other kind of motor, is you use a set of start and stop buttons. The start button is a normally open switch, and the stop button is a normally closed switch. The contactor is essentially just a big relay. It has to have a coil energized in order for T1 to connect to L1, T2 to connect to L3, L2, and T3 to connect to L3. We directly connect one side of the coil to one leg of the three-phase. A second leg of the three-phase then goes over to this momentary start switch, which is normally open. The other side of it feeds through the contacts on the phase monitor, which then goes through the contacts on the thermal overload, which then goes to the other side of the coil. So for this coil to activate the relay, both sides of it have to be connected to two different legs of the three-phase. So as long as the phase monitor is seeing good three-phase power, these contacts will be closed. And as long as we're not seeing an overload condition, these contacts will be closed. Of course, if there's no power going to this, these will be closed. So when we momentarily push the start button, that connects this second leg of the three-phase through the start button, through the phase monitor, through the overload, to the other side of the coil, energizing the coil, which then connects across the contacts on the relay. Now this becomes a latching relay because of this connection up here. We take this second leg of the three-phase and we feed that through the stop button. The stop button is normally closed. So when we're connecting this, if we press down on the start button, all of these are connected to the same second leg, because we're connecting across the relay, we're connecting through here, we're connecting back to the same second leg, and that's important. You can't put this on two different legs. If I let up on the start switch, because this relay is energized, this current is flowing through the stop switch. Well, that then backfeeds along this path through the closed contact of the phase monitor, through the closed contact of the overload to the coil. At this stage, this relay is latched. Power is headed to the motor or to the forward reverse controls. If I push the stop button, that breaks the circuit. So that second leg, which is energizing this side of the coil because we go through this loop, when that breaks, that causes the coil to be de-energized, which then breaks the relay contact. Now, anywhere along this path, if there's a break in the circuit, the relay becomes de-energized. If the phase monitor sees too high of a voltage or too low of a voltage or doesn't see all three phases, it opens up this set of contacts. Opening those set of contacts is no different than pressing the stop button. If the thermal overload detects an overload, too many amps running through it, it will open up these set of contacts, then de-energizing the coil, just as if you had hit the stop button. So what this gives me is a few layers of protection. I've got the short circuit protection here in this breaker. I've got the phase monitoring protection with the phase monitor. I've got the thermal overload protection with this. Now what this means is I cannot turn on the lathe unless I'm seeing all three phases. If the lathe starts overloading, the motor starts drawing too many amps, it'll cut off power to the relay, which will cut off power to the motor, protecting the motor. Well, while you were getting your lesson in how I integrated these components, I drilled and tapped all of the necessary mounting holes that I need to mount the components to this piece of aluminum, and then also to mount the aluminum into the enclosure. Both the phase monitor and the breaker are attached using a piece of DIN rail, which I'm mounting here to the aluminum base. Here I'm mounting the thermal relay on the left side. Now, where these are mounted really has no bearing on how they function. It's just how I wanted them to be attached to the board that would give me the easiest path to wire everything together. Next is the contactor. I'm mounting it with 3 screws. The location of where the fourth would have been, I needed to cut that away to make room for the mounting hole to when we mount this whole contraption on the back of the lathe. Now I can clip on the breaker and the phase monitor. Well, for the internal connections of the 3-phase power, I'm going to be using this 12 gauge stranded copper wire. My first connections are going to go from the output of the breaker to the input of the contactor. I am trying to keep this wire as neat as I can get it, and I am taking the extra step to make sure that any of the numbered terminals here stay within the same numbers. In other words, terminal 1 on the breaker will go to terminal 1 on the contactor, which will then go to terminal 1 on the thermal relay, etc. And that would just make troubleshooting this, if I do have any issues later, a little bit easier. And now next, the output of the contactor will go to the input of the thermal relay. Well, next I'm going to run 3 jumpers from the input of the contactor down to the phase monitor. These contactors have 2 extra terminal lugs on each of the 3 inputs and each of the 3 outputs of the relay. So it makes it easy to add additional connections without having to double up any wires on any one connector. Well, next I want to start wiring up the coil. So we'll connect a lead here to the common side of the relay coil. This is the one that will get routed through all of the different contacts. We'll start by connecting one side of the coil to one of the contacts on the thermal overload relay. Now I will route another wire to the other contact on the thermal overload relay and then take that to one of the contacts on the phase monitor relay. I'll connect a wire here loosely to the other side of the contacts on the phase monitor relay, and this will eventually route to the start-stop buttons. We'll create another wire here for the start button, which is why it's green, and it will connect to the input of the second leg of the 3-phase power, so L2, and we'll take this and route it around to one of those lugs on L2 of the contactor. Feel free to tell me in the comments why I shouldn't have used green, because green is for ground and I should have picked another color. While I'm back here, I'm going to make a small change. I'm going to take the jumper that we have going from the coil to the thermal overload, one of the common wires, and I'm going to move it over to the other side of the coil because I need to create a jumper from L1 to the coil, and I think it would just be a little bit easier to go straight up and down rather than across. And next we'll create a jumper for the other side of the stop button, and we'll connect that to the output of the second leg on the contactor, so that would be T2. And now I need to connect the other side of the coil directly to the L1 input from the three-phase. Off camera, I mounted the start-stop buttons into the front panel of the enclosure here. Now I'm just taking that blue common wire, which comes from the phase monitor relay, and I will connect it to one each of the inputs of both the start and the stop buttons. And then the red wire connects to the other side of the normally closed contacts of the stop button, and the green wire will attach to the normally open side of the start button. With all of the components and their interconnections made and double checked, I can power this up and run some tests. I have one end of a three-phase power cord here with the wire stripped, and on the ground wire I have a ring terminal that I am attaching to the aluminum base plate with a 1/4-20 tapped hole. Now I can attach the input power to the breaker. Now in all of the components, I always wire everything the same way. I always wire L1 as black, L2 is red, and L3 is white. I do this because I know that L3 is my generated leg. So I know that the white wire is the generated leg, and you never want to use the generated leg for any control circuitry. So the coil in the contactor is energized by L1 and L2 only, never L3. Okay, I have the other side of the power cable plugged into the phase converter, but the phase converter is not on. And you'll see I have voltage between L1 and L2, but I have nothing on L3. Well, with that checking out okay, we can go ahead and throw the breaker, and we should see the phase monitor come to life. And you can see here it's showing 112 volts, which is about what I would expect to see without the phase converter running. Now there are some settings in here that I want to change, and the first one here is the over voltage threshold, and I'm setting that at 260 volts, and that is kind of arbitrary. Essentially, this will trigger an error condition if the input voltage exceeds that value. The next setting I want to change is the under voltage threshold, and I'm going to set this at 210 volts. Again, if the input voltage falls below 210 volts, it triggers an error condition. The next setting I want to alter is the start delay time. I'm going to set that to 3 seconds, and that just gives the phase converter a chance to even out before it throws an error condition. The last setting I need to do is change the frequency to 60 Hz from 50. So the phase converter is currently off, so pushing the start button should have no effect because the phase monitor is seeing that it doesn't have clean three-phase power, it's under voltage, so it won't allow the start button to do anything. I'll walk over to the control panel for the phase converter and turn it on. And you can see now that the phase monitor is showing 250 volts now. I'll use the voltmeter here to take a couple of measurements. I'm still showing 0 volts here on the output to the contactor, but the inputs are now showing 230, 240 volts on all 3 inputs. So pressing the start button now should energize the coil on the contactor relay. And now I should see that 240, 250 volts on all three legs on the output of the contactor, as well as the input and output of the thermal overload relay. And then pressing the stop button will de-energize the relay and all outputs will be 0. We'll start this again and test the thermal overload by pushing the red button on the thermal overload, and that should de-energize the relay. Well, the last test I can do here is I'll energize the relay, and then I'll walk over to the phase converter and turn it off. And as expected, once the phase monitor saw that there wasn't a good three-phase condition, it de-energized the relay on the contactor. Well, off camera, I took off that old junction box and the old contactor and replaced it with our newly built one. And with the phase converter off, you can see that the start button does nothing and the forward reverse control does nothing as well. We'll go ahead and turn on the phase converter. And now I can energize the contactor and turn the lathe on. Pushing the stop button will kill power to the lathe. I'm considering adding a remote button to the front as an emergency stop. One thing I have to do yet is to properly set this overload dial to the right amperage setting. Right now it's on its lowest setting, but there's no load on the machine. We can test it and it will kill power to the lathe. And if I kill power to the rotary phase converter, the phase monitor will detect that and then automatically cut power to the lathe. That little click that you just heard was the phase monitor relay engaging once it detected clean three-phase power. Well, I hope you found this entertaining. I will repeat that I am not an electrician. I am not giving you advice on what you should do in your shop. Well, if you liked the video, give it a thumbs up. If you're not a subscriber, please hit that subscribe button. And thank you to all the subscribers. And a big thank you to all the Patreons and others that have donated to the channel that make this kind of content possible. Thanks for watching, and we'll see you on the next one.